Okay, so here's another redox example. And of course, reduction, oxidation is what redox stands for, and it's a special type of chemical equation where there is one element that is being reduced and one element is being oxidized. And in order to find out which one's being reduced and which one's being oxidized, we have to examine the net ionic equation, which I believe we almost have here. Looks like this H2SO3. Okay, that's a weak acid. It's in aqueous form. So actually, we're going to write this as, instead of H2SO3, we're going to write H plus HSO3 minus. Okay? All right? So we're going to separate those things that are soluble or those things that are aqueous in nature. Okay? So these are all ions. So this is a liquid right here. So now we're good to go. Aqueous, aqueous. Okay? So, oxygen and hydrogen, don't worry about those. Those are 99% of the time not being oxidized or reduced. We need to focus on the other elements. So manganese would be a good one to focus on, and sulfur would be a good one to focus on. So let's take a peek and identify what the oxidation states are and see what's happening from reaction side to product side. So MnO4, well, oxygen is 99% of the time it's -2, right? So that's a -2 for oxygen. Now there are 4 oxygens, so that's a total of -8 that the oxygen, of course, sort of has as a total state there. This is a -1 charge. So what number, when added to -8, gives you -1? Plus what? 7. Very good. So manganese is a +7 over here. That's the oxidation state. Okay? So it has an imbalance of electrons, and it's a +7 to start with. So let's check out to see what manganese becomes on the other side. Well, this is easy. This is in ionic form. So what's the oxidation state for this? It is +2, right? 2+. So it's this charge of the ion. If it's a monatomic ion, it's always the charge of the ion. So manganese has gone from a +7 to a +2. And is that, so remember, losing electrons is oxidation. Gaining electrons is reduction. So it's become less positive, so it's gained negatives, right? So it's gained electrons here. So this is the reduction half. All right, so that's what I would suggest. You kind of separate the page into two parts, and we'll do reduction half and oxidation half. And the reduction half then includes or involves MnO4 minus, and that becomes Mn2+. Now we're going to have to balance a few things. Oh, what did I just do there? That's supposed to be an N. We're going to have to balance a few things, but that's coming. Oxidation half. Let's see if sulfur really is being oxidized then, because it looks like sulfur should be the one that's being oxidized. So each oxygen is -2, each hydrogen is +1. This is a -6 in total here. This is a +1 because there's only one hydrogen there. And it has to equal -1. So what's the number in between here? 4? Does it look like a +4? So 1 plus 4 minus 6 is -1? Yeah? Did I do my math correctly there? Hope so. Say, what about over here then? So we have each oxygen is -2. That's a -8 in total because of that 4. All right. The hydrogen is +1. And this all has to equal -1. So what number goes in here to make this math statement true? 6. Okay, so a +6. All right, so the oxidation, so the S has gone from +4 to +6. Okay, so that means it's lost 2 electrons, hasn't it? It's lost electrons, so it definitely is in this oxidation half. Sulfur has lost electrons. So we need to write the species that sulfur is in on the reactant side and from the product side. So the oxidation half looks like this. HSO3, that's the species that it's in, has got to turn into HSO4 minus. Okay? Any questions there so far? All right. Okay, so now we start balancing now, okay? So we balance atoms other than hydrogen and oxygen. So the manganese, we have one Mn here and one Mn here, so we don't have to balance those. That's great. So let's focus on the reduction, follow it all the way through here. So we have to balance what next? Oxygens. We balance oxygens by adding the appropriate number of water molecules, right, to the appropriate side. So I've got 4 oxygens here, I've got 0 oxygens here, so I'm going to add 4 waters over here, because now my oxygens are balanced. 4 oxygens here, 4 oxygens over here now. So after I've got my oxygens balanced, I have to balance my hydrogens now, because I just added hydrogens along with that oxygen. So I've got 8 hydrogens over here, I have none over here, so I got to add 8 H plus ions. And all of these are in acidic solution, right? So that's a given. We're not going to be doing basic, okay? That's not too much harder, but we're just going to focus on acidic here. So all these examples are in acidic solution, which means I have lots of H pluses floating around to use in an equation, okay? All right, so the final thing we need to do is balance charges. And we can balance charges by adding electrons to the appropriate side. So what are the total number of charges over here? I have 8 plus and 1 minus. So what is that? That's a total of 7 plus over here. You see that? And what about on this side? I have a total of 2 plus. So where do I need to add electrons? Well, in the reduction half, you should have to add electrons to the left side here. So I got to add 5 electrons. Do you see that? So 5 electrons will balance those charges. Stop me if any of this is not making sense. Okay, what were the charges here? So I have 1 minus, just 1 minus charge, right? I have 8 positive charges on this side, and then over here I just have a 2 plus charge, and then this is neutral. So here we go, 1 minus, 8 plus, I have 7 plus in total over here, and a 2 plus in total over here. Okay, so it's just the charges on the ions. Yeah, does that help? Okay, so let's do the same over here. Let's do the same over here. So the S's are balanced, no problem. I don't have to do anything. Again, if this was S2, let's just say this was S2, guess what? I would put a 2 here. That's what I'd do. If you had to balance the S's, you would just do it like you would normally in a regular chemical equation. But we don't have to do that. So these are good. Let's balance the oxygens. Well, I have 1 extra oxygen over here, so I'm going to put a water over here. Now my hydrogens are balanced both sides. Hydrogens. Oh, I've got 1 here, plus 2 is 3 over here. I only have 1 over here. So in order to balance those, I have to add 2 more hydrogen ions over there. And now I take a look at charges. I have a 1 minus charge over here on this side, and I have, what do I have over here? Well, I have 1 minus and 2 plus. So what's 1 minus and 2 plus? That's 1 plus, right? Okay. So I need to make these equal. So what am I going to do? I'm going to add electrons to this side. How many? I'm going to add 2 electrons to this side to make this a -1. All right, so as we continue on, what we need to look at is we need to look at the electrons, right? I have 5 and I have 2. Still frozen? All right. So I have 5 and I have 2 electrons there. So I need to make them equal, right? So if you have to multiply both sides by, by a constant multiplier, then that's what you have to do. So I guess the common multiple here was going to be 10, right? So let's multiply this one all by 2. And these guys all by 5. Okay, so over here I have now 2 MnO4 minus plus 16 H's, H pluses, plus 10 electrons. I also have 2 Mn2 pluses plus 8 waters. And this one in blue. Over here I have 5 HSO3 minuses. Say 3 right 4. I have 5 waters, 5 HSO4 minuses, 10 H pluses, and 10 electrons. Okay. Everybody okay so far? All right. Once you get practice with this, once you get the hang of it, it becomes not that hard. You just got to make sure you copy everything down properly. So now we should have the same number of electrons on opposite sides of the arrows. So that's good. So now what we're going to do is we're going to be able to just straight add up these equations. Okay? Just straight add them up. So I'm going to take this and I'm going to move it down here. And you can rewrite something if you want to, but I'm going to take this and I'm going to kind of line up the arrows, I guess, a little bit. That's the way I like to kind of do that. And so right away I see that the 10 electrons are going to cancel out with the 10 electrons on the other side. So that's great. We do not want electrons showing up in our final redox balanced equation. That's not cool. We've done something wrong if that's the case. Everything else that is the same species on both sides, we can start to cancel off. So I'll just write my little equal sign here when we add these up. So I'm looking at the hydrogens here. I'm looking at 10 over here, 16 over here. If I take off all 10 here and 10 of those, I'm left with 6 hydrogens here, right? Okay, anything else that's the same? Well, looks like we've got some waters here. Water molecules. So if I take off all 5 of those and 5 of those, I'm left with 3 waters there. You good with that canceling out process there? Okay. Anything else that's the same on both sides? Well, this is close, but this is definitely not the same, right? HSO3 minus HSO4 minus. You can't combine those. Those are not the same. So everything else we just copy down now with the same coefficients and everything that we see. Okay, so I've got that one done, that one done. Yes. Okay. So the moment of truth here now. Let's wait. What number was this? 5. Okay. So what you might find, guys, is that there is a chance that, now in this case, I think in the textbook here, if you look at the answer here, they didn't split this, they didn't actually split this acid up. Well, it is a weak acid, and it was aqueous. So we are well within our rights to do that. I would suggest you do that. But I'm just noticing here in the back of the book, they have H2 here and don't have as many hydrogens. Okay, so they have the hydrogens here accounted in here. But, you know what, it's a weak acid, we'll let some of it dissociate, okay? So that's okay. I'm cool with that. You can discuss that in university, whether that's, take a look at the Ka values and make a decision there, but this is good, okay? And then everything else looks to be same. All right, question, yeah? Will you ever have to cancel things on the same half reaction? Yeah. You shouldn't, no. No, shouldn't have to. It'll usually be canceling from one side to the other side. That's it, yeah. Okay, good. Any other questions?